So we are solving here a matrix median problem. So we have given a array, I mean matrix 2D 3D in this matrix, and we have to find the median. So we have to find the median. So I can think of over here, like I have given this value, this values, and here is the sorted form of those values. So I can, so to find the median of this particular array, I with the binary search, with the binary search I with the binary search I just want to know that for each element, does this is a median or not. Thus, suppose if I pick a 4, so I just want to know, does my fourth element is a median or not. So how do I know it? Suppose I have given the length of this particular array is 3 9, okay, 9. So 9 by 2, so this is the length, and I did a half. So whatever is the median of this particular array, that will be a half of this array. So here half is fourth, 4.5, so we'll take a 4, 1 2 1 2 3 4. So here are 4, 4. So we took off this over here a 5. So basically over here we took a just a greater element, just a upper bound of this 5, like half of this 5. So basically over here, if I pick a 5, so I just want to know that if I pick the 5, I want to know how many elements are less than and equals to 5, less than 5. Suppose over here there would be a 1 5 more. So in the that case I just want to take care of this case by equal. So by this way I will be knowing that how many elements are less than and equals to 5. Okay, so this is the thing I have to think. So how do I pick up a random element? I cannot pick up linearly because it will end up making to a complexity of big of n cross m. So what I will do is I will pick the element in a binary search way. So I will do a binary search on these numbers, and I will pick any random number and see that particular number is satisfied this condition. Suppose first I picked a four. Suppose I pick a 4, so I have to check does how many elements in this particular matrix are less than and equals to 4. So by getting that number, I will compare I will compare uh, by getting that number I will compare that in which direction I have to move. I have to eliminate the left search space or have to eliminate the right search space. So this thing I have to take care. So first thing is to like do a binary search on this matrix to pick any random number, then do other computation to know that this particular number which I have picked by the binary search, does this particular number has how much less than or equals to number. After that, knowing that less than or equals to number, I will eliminate the search space. I will eliminate the search space, either left or right search space, depending upon in taking a consideration of that how much required number I need. So I'll do a code of this, and I'll explain while coding, so it will be a more clear what I'm thinking. So I have given this matrix, so I'll take first n row matrix dot length let m equals to matrix 0 dot length over here. So this is a thing. So as we discussed, like there will be a required number, like that will be a required number which that will as we discussed, like there is a required number which will tell me to eliminate the to eliminate the left or right search space in the binary search, uh, because I will pick any random value from this matrix and want to confirm that does this particular value is my median or not. Okay, then required number is minimum is n cross m by 2. So I just have to do a math dot floor over here. Okay. This is the thing. Now I just have to define my low and high for the search space. Low is minus infinity, and as of now this is minus infinity, and high is equals to infinity. So this is my these are my range. So I just have to traverse this matrix to get the low and high. So as it is row wise sorted, I just have to travel the first and last uh, last row. So for let I equals to 0, I is less than n I plus plus row I plus plus. So here I will do low equals to math dot minimum value from the first row. So we'll take 0 and matrix matrix not 0, low matrix. I just have to traverse I and 0, column will be 0 over here, and same with the high is equals to math dot max high, which is currently I have right now. I just have to take minus infinity over here and positive infinity over here, and high over here I have to take a matrix, and I is over here, and the last column over here. By this way I have high and low. Now I just have to do a binary search on this matrix to know to pick a element and to check whether it is my median or not. So while low is less than equals to high, I did this. Low is less than equals to high, let mid equals to math dot floor so mid dot equals to math dot floor low plus high by 2 low by high by 2, like this. We have find out the mid over here. So after finding the fed, we just have to calculate how many elements are less than and equals to this particular mid. So let count number and this dot count, I'll take it. I just have to pass the matrix and this mid value and n and m. Okay, these are the things I just have to pass, and when it will return me some count of numbers, then I will check that count of numbers, does that lesser than or equals to my required value. If it is lesser than my required value, then I have to increase the numbers. So if count num is less than or equals to required value, then I have to need more numbers. Look, mid plus 1. Otherwise what you do, high equals to mid minus 1. Okay, now I just have to count matrix over here what I have passed, matrix, okay fine, and mid, take it as x, n and m. These are the things I have passed over here. So count I have over here. So I just have to check that particular x value has how many low, how many less than or equals to element. I have to count that. So count equals to 0. I'll do one thing over here. For that to count those numbers less than and equals to a mid, or either I say x, I'll pass a row one by one. I equals to 0 and I is less than n and I plus plus over here. And what I will do, count, I just have to count plus this dot upper count values of count values in matrix count values in matrix, where I will pass this first row which is I, and I will pass x value obviously and m. Okay, then over here return, when I have the count, return the count. Over here I have one matrix, one row. Okay, I'll take it array. There is a x which is mid and m over here, fine. So let ans over here, which has a let ans which will have the final answer. So I have a row, particular one array. I just have to figure out how many elements are less than or equals to the given x. So basically that is upper bound. So what I'll do, I'll apply a binary search, low let low equals to 0 and high, yeah, I'm right, high equals to m minus 1. So low is less than equals to high. Over here what I'll do, I will take a mid, let mid equals to math dot floor low plus high by 2. Over here we have this mid, and if this mid value is greater than x, if this mid value is greater than my past value, my guessed value, if it's greater than, then I have to do it a bit, reduce it high. I have to store first, if I'm finding upper bound, so I have to store this. I have to store this mid, and just have to reduce it bit to get a bit more lesser value which is greater than my x. High equals to mid minus 1, and else will be low equals to mid plus 1. So this is the thing. At the end I will return answer, return answer. Initially ans would have m. Okay, now initially it, okay, then it will return count. At the end we'll decide how to eliminate the spaces over here. Then I have to return low when they crossed. Okay, we got the answer. Let's try to submit it. So yeah, it is submitted perfectly. So basically what we did in our overall recap, I did a binary search on the matrix. So this binary search on a matrix is a guessed guessed search. So I picked up any random value from the matrix with the help of binary search and figure it out, like how much elements are less than or equals to this median mid element. So after getting that number particular, how much elements are less than equals to median, I will try to eliminate the spaces of what number I have to pick next. If that number will be a smaller or equals to or my required number, I just have to increase the mid, otherwise I have to decrease the mid. So over here I am finding the upper bound, just one element which is greater than my mid, which is just greater than my mid. So I have doing this over there.